Now let's start doing each of the steps one by one. The first thing that I would do is I would create container on a local machine. This is my local machine, and in this directory I have Docker file, and I have a Python web program, first python-webpage.py and requirements.txt, and these are the same programs which you have already seen in the Docker demo. And this is the command to build the image, docker image build, and then tag would be python web page container :latest. Anyway, I'll have to change the tag because I'll be uploading this image to Docker Hub. But before doing so, let us test the application, or let us test the container. Sorry, my Docker daemon is not running. I'll have to start the Docker daemon. The Docker daemon has been started, and now let us go ahead and create the image. I have removed all the previous images so that this is started from the beginning. And as you already know that it will take some time to build the image. So the image has been built. Let us go ahead and check. So this is the image. Ubuntu is the base image, and on top of it Python web page container image has been built. Now before pushing this image to Docker Hub, I want to run a container out of it, and this is the command to run the container from this image: docker container run -d, that means in detached mode. I'm passing this environment variable capital NAME. Then the name of the container would be K8s-container1 with host port 8080 mapped with container port 8080, and followed by the name of the image. So let us run this container and see whether this container is running or not. So this container is running, and we have started it just now. Let's try if the application is really working or not from the web page. So this is the endpoint, or this is the URL: localhost :8080/Kubernetes. Make sure to put Kubernetes here because that is how we have defined the path inside of the program. So once that is done, I am getting this output: hi Shomodeep, welcome to K8s session, followed by the web page which I have. Not operational yet though. Anyway, so it is working. Now I can push this image to Docker Hub because this image is up and running. Before that, I have to log into Docker, and now I'll have to tag the image. And this is my Docker Hub account. I have created one more repository, and the name of the repository is K8s-EKS-GKE. So I'll have to tag the image with this repository name: deepcloud2208/K8s-EKS-GKE. Get the image ID and change the tag of the image ID. So now the image tag has been changed: deepcloud2208/K8s-EKS-GKE. Now I am ready to push this image to Docker Hub, and as you can see, the image ID is same for both of them because they are actually representing the same image with different tags or different image names. So now I'm ready to push this image to Docker Hub, and this is the repository name: deepcloud2208, which is my Docker Hub account, / the name of the repository, which is K8s-EKS-GKE. It'll take some time for the image to be pushed in Docker Hub. Okay, so now the image has been pushed. Let us go ahead and check. This is my repository, and now I should have one image here, which is this one. So if you see, this repository has this Docker image, and it was pushed a few seconds ago, and you can also get the push command from here. All right then, so we have created one image that we ran a container from that image which was running successfully, and then finally we pushed the image to Docker Hub. Now before going further, I want to do one more thing. I want to push one more image to Docker Hub so that we can have two containers, and we can create a pod with one container first and then two containers. So I'll be creating two pods. The first pod would be with one container, and the second pod would be with two containers. So this is the image. Let us take a look at the Docker file. Very simple. It is installing CentOS, and then it is installing Apache HTTP. I'm copying the index.html file, and then I'm running this command and exposing port number 8000. I'll name this image as HTTP web page container. If I do not provide any tag, the latest tag would be taken. So now the image is being built. Once the image is built, I'll run a container out of it, and if everything runs properly, then I'll push this image to Docker Hub again. Now it is extracting the operating system again because the previous operating system was Ubuntu and this is CentOS. So that's why it is downloading the base image, and then on top of it, it is doing other stuff. Okay, so the image has been built. Let us go ahead and take a look. So this is the image, HTTP web page container. And now let us go ahead and run a container out of it. And this is the container run command, docker container run d. The name of the container is Kubernetes container 2. Sorry, it gave me an error because it should be 0 rather than O. And let's see whether the container is running or not. Alright, so the second container is also running with the name Kubernetes-container 2. Let us see whether we can access this web page, and it should be localhost colon 8000. There's no endpoint. Alright, so it is not working. So the problem has been fixed. The issue was that I was running HTTPD on port number 8000 inside of the container, but I did not change the configuration of HTTPD file, which is in etcd httpd conf directory, but that needs a lot of changing. So what I have done is I have changed the docker file and I have exposed port number 80 here, and while running the container I'm using host port 8000, which is mapped with container port 80. So now if I go to the browser and try localhost 8000, I should see an orange page saying that hello, I am a container inside of a Kubernetes pod. Actually, it is not inside of a Kubernetes pod. We're still away from it, but the container is up and running. It is working fine. So it is perfectly safe to push the container in Docker Hub. But for that, I'll have to create one more repository, and I have named the repository as HTTP web page container. As you all know, we'll have to tag the image again. So the image has been tagged, and now I'm ready to push this image to Docker Hub. The image has been pushed. Let us go ahead and check the repository. If I do a refresh, I should be able to see the image which has been pushed here. So there you go. The image with tag latest has been pushed to this repository. So alright, so first two steps are done. We have created a container on local machine. Basically, we created two containers on local machines, and we uploaded both the images to Docker Hub. The next step is to create a Kubernetes cluster, which is already there using kubeadm from the previous section. We have created the cluster using kubeadm, which has one master and two worker nodes. Now what we'll do is we'll use the same Docker image, or basically the same images which has been posted in Docker Hub, to deploy a pod on the cluster. I created the cluster using Google Compute Engine instances. If you want, you can use your virtual machine, or you can use EC2 instances also. But this is not a managed cluster. So this is a non-managed cluster, and it has been created by us. Before going further, I want to show you the manifest file of the pod that we are going to create. The name of the manifest file is myfirstpod.yaml. It's a very simple manifest file. So it starts with API version with v1. The kind is of course pod. In metadata, I have mentioned name. Kubernetes pods intro 1. So this will be the name of the pod. There are two labels. One is environment training, and the second label is key chapter and value pods. Then in the specification, I have mentioned two containers, Python web page and HTTP web page. So this pod should be created with two containers. Here I'll have to copy and paste the image ID. So these are the two image IDs. DeepCloud2208, which is my Docker Hub account, and then the repository name for the first image is KTS-EKS-GK, and colon the tag which is latest. And similarly, the next image is DeepCloud2208 HTTP web page container colon /. These are the two image IDs which are in Docker Hub. What Kubernetes will do behind the scenes is that Kubernetes will do a Docker pull and try to get these two images inside of the pod, and then it will launch the containers using these two images. So you just provide the image ID from Docker Hub, and Kubernetes will automatically pull the image, run a container from the image inside of the pod. So if you're using private registries like AWS ECR or GCP's container registry, then it is a little different, which I'll show you later on. So this is the first YAML file, and I'll be deploying a pod using this YAML file. Now I can install kubectl in my local machine and then run the command from here. But what I'll do is I'll log into the master node and run kubectl command from there. So now I'm inside of my master node. Let us see if the nodes are still running or not. So all the nodes are running, and what I'll do is I'll have to copy, or I'll have to create the manifest file here itself, because I'll be using kubectl apply command Okay, so I have created the manifest file and now I should be able to deploy this pod in my Kubernetes cluster. To create the pod, we have to run this command kubectl create -f followed by the manifest file. In our case, it is myfirstpod.yml. Now, once it is done, the pods must be running. So you can run kubectl get pods command to get the information about the pod. Now, something interesting has happened here. I actually ran this command approximately 12 minutes back. Now, what is showing is, first of all, it is showing the name of the pod. So here the name of the pod is Kubernetes pod intro 1, which we had given in the manifest file. So this is fine. Now in the ready column, it is showing 1 by 2. The 2 on the right hand side is actually the number of containers this pod should contain. Of course, it makes sense because in the manifest file we had provided 2 containers. But here we are seeing that the number is 1. It should have been 2 by 2, but it is showing 1 by 2. That means one of the containers is running, but the other one is not running. Then it is showing a status of crash loop back off. That means one of the containers has crashed and it has tried 7 restarts, but it was not successful. You can control the number of restarts, but we'll go into that detail later on. So let us go ahead and see which container is running and which container is not. Now these are the typical errors which you might get every now and then. So it's better to see how to troubleshoot these type of errors. When you want to get information or detailed information about a node, what command do we run? We run kubectl describe command. Similarly, here we'll run the kubectl describe pod command followed by the pod name, which is kube pods intro 1. Let me pipe it to more. Okay, so it is showing a lot of information. The first is the name of the pod, which is Kubernetes pods intro. Then something called namespace, which we'll discuss later on. Then the labels. So in labels, the labels that we had mentioned in the manifest file, chapter is pods and environment is training. There are no annotations. Now this one is pretty interesting. It is showing the IP address of the pod. So if you remember, when you created the cluster, we had mentioned -- pod cider. We had mentioned the pod cider address and we had mentioned a network range of 10.168.0.0/16. So the IP address of the pod is 10.168.1.2 and it is following the network address range which was given in -- pod network cider. Okay, then it is showing the container information. So this is the first container, Python web page, because this is what we had mentioned in the manifest file. And then the container ID, the image where this container has been launched from, the ID of the image inside of the pod. Port and host port is none as of now. That is fine because we have not mentioned anything here. We'll discuss this later on. The state is waiting and the reason is crash loop back off. So seems like this container is not running inside of the pod. And the last state is also terminated because of error reason. It is not showing you the detail of error, which we'll see shortly how we can find out the error. And then ready is false, of course, because the container is not running. The restart count is 7. That means Kubernetes tried to restart this container 7 times and it failed. And we are not passing any environment variables. And there's something called mounts, which we'll come back to later on. The next container, whose name is HTTP web page. This is the container ID. This is the image ID pulled from Docker. And this is the name of the image, which has been pulled from Docker. No host port and container port. And the state is running. So seems like inside of the pod, one of the containers is running. And it was started. This ready status is true. There is no restart count. There are no environment variables. There's some mount points, so on and so forth. Then it is showing some more information like volumes, QoS class, node selectors, etc. Then there's one more interesting information, which is events. Now in the events, it will tell what the pod did from beginning. So initially, this is the oldest one. It successfully assigned this pod name, namespace / the name of the pod, to the worker node 1. So this pod has been launched in the first worker node. We can see this in a different way also, but in the event also it is mentioning that it has successfully launched this pod in worker node 1, and then it is pulling image from http web page container, which is a docker image. The image was successfully pulled, the container was started, then it pulled the second image, which is also a docker image hosted in docker hub, and the name of the image is kts-eks-gk. Container created, tried to start the container, it started the container as well, and it is also showing that the image was successfully pulled. Now after some time it is saying that back off restarting failed container. So seems like one of the containers have failed. Now how do you know that which container has failed? I have already shown you using this describe command. So you can use this describe command to see what is happening inside of the pod. Now in the pod events, you can see that which the pod has been launched in which node. There's one more option which can be used to find the information about the pod where it is running on which host. And here you already know this, which is -o white. It is showing that this is the name of the pod. One of the containers is running. Status is crash load back off. It has tried 8 restarts that container. This is the IP of the pod, and this pod is running in the first worker node. And forget about nominated node and readiness gates, that is fine. All right, now the next thing is we have to troubleshoot what happened inside of the container, why it failed.